Let's let's continue what we were doing last time. So yeah, and queens, the n queens puzzle is the problem of placing n queens on an n by n root chessboard that's such that no two queens attack each other. Given an integer n, create all distinct solutions to the n queens puzzle. You may return an answer in any order. Each solution contains a board configuration of the n queens placement where q and period indicate a queen and an empty space respectively. So a matrix size 4, these are the answers, right? The queens aren't attacking anyone, so that's the first one. The second one, there exists two distinct solutions to the n queens, as shown in the puzzle. Okay. So I need to keep track of all the diagonals, right? And columns. Okay. I think I got the intuition. So the backtracking solution would work as follows. So we would have okay, so we have one, so we have an n by n board, so we'll have for every here we'll have them as lists, and then once for the final answer, it looks like it wants us to have it as a string. We'll just join them together. Okay, so we need to have how many things? Row, column, diagonal, and is there a word for this? Okay, yeah, diagonal. Diag 1. We'll call this diag 1, diag 2. So diag 2 means going from right to left. Diag 1 is going from left to right. We'll have a set for 4 sets. 4 sets. We have 4 sets. Row, call, diag 1, diag 2. Meaning left to right, right to left. Straightforward, I think, right? Okay, yeah, that makes sense. So backtracking, we'll kind of as we place it, we'll place it on a board, right? And if it works, then that's perfect. And then we'll remove it after the backtrack so we can try another possible one. Right? We're gonna try here, try here, try here, try here. This is actually gonna be super bad though. It's probably like n factorial. Okay, luckily though, there's only 9 cases that I need to test out. Okay, so we do this. Okay, now how do we test? We should always move on to the next row. If I can place it on the row, I just need to make sure that I'm on the right column. And once I find the right column, I need to make sure I need to know I'm not on the right. I'm not on I'm stepping on some anti-diagonal position, you know? So I know for sure I can't go here, here, here. So the only position is here. So when I place a value, I need to put the row, the column it's in, the diagonal position. So the diagonal I can probably do, it's like probably like, I remember from like previous matrix problems, we'll do like from r minus col, diag 2, going from this way, that's r plus col. For example, this is 0, 0, or it'll be 1, 0, and that's diagonal position is 1 plus 0, meaning your here and here are going to have the same diagonal. So this is 0, 0. This is 1, 0. This is also 1, 0. So this is a group of 1, group of 2, right? Because this is 2, 0. This is 1, 1. This is 0, 2. So they all equal 2. So they're the same. Same logic going this way. So this is actually the difference this time. So this is so this is 5, 0, or 0, 1, 0, 1, 2, 3. So 3 minus 0, 3, right? So that's negative 3, I guess. This is gonna be this is 0, 2, 0 minus 2. This is 1 minus 3, which is negative 2. So the same thing. They're just like negative indexes. I mean, I can multiply it so that it stays positive, but I think they're unique enough in my opinion. So that keeps track of all the diagonals. And yeah, basically just try and then go through that whole branch and then pop them out of the sets and, you know, keep going. So let's try it. Okay, I'm gonna create the board. So we'll just do, we'll have a board and we'll have, just keep times n for in range. So let's print the board. Let's just have like an empty board for now. Yeah. And then with the def backtrack. Backtrack. Okay, so the backtrack's gonna take multiple sets. So current row, we'll do the current row index to which row we can go, and then we'll do row set, call set, diag1 set, let's call it d1 set, d2 set. Yeah, we'll call that. So we'll pass in basically 0. Oh, I need this one. 0. Pass in 0 and all empty sets. Yes, set. So 4 different sets, and then we'll do okay. I need to hold multiple boards. Yeah. Okay. Okay, that's fine. We'll do res here, and then we'll actually pass the res too. God damn, this is the long ass solution. Oh, yeah, we'll pass that in. And then So the base case is if cur row equals n minus 1, right? So we've reached it to the end. That is the answer to do. So we'll do basically get all the rows, right? All the rows and snapshot it. So I'll call it cur board. I'll just like make a copy of the board, right? And then for every row in cur board, I'm going to answer the append dot join row. Yeah. And then yeah, so I don't alter the board, and then we just return out. Okay, that's the base case. Like we'll go through all of it, and then we're gonna backtrack. Cur row plus 1, row set, call set, d1 set. Do I need to call them sets? I don't think it's necessary. d1, d2. Yep, okay. Okay, so this works. Okay, so we call and we just keep going for every row. And then I need to basically check, okay, within the current row we're on, right? So board of, first off, you need to check, okay, if there is cur a row in row, then obviously return out, right? Or okay, we need to go through, we need to enumerate the current row we're on. So we need to do this. We need to go through everything. So for every call in board of cur row, for every column in board cur row. So first off, if cur row in row, or in row, or row plus column, or row plus column, or row minus column in D2, or row plus column in D1, that's D2. So this is D1, yeah. Return. Otherwise, that's a valid cur row combination. So we will do, we'll add it. So we'll do basically board of cur row equals a queen now, a column And then we need to do row dot add cur row dot or call dot add cur row just column column. Okay, that's actually bad. Actually, let's call this C instead. C, and it's also cur row. Okay, yeah. So this is that. Mark it at, call that at the C, and D1 dot add the row. So cur row minus C. D1 dot add cur call plus C. And then we're good here. Then we backtrack, right? And then we remove everybody. We undo this process. So we, backtrack and then undo this process. So we undo this process, put a period, discard, discard. Damn, I wish that this is a lot of boilerplate. Yeah, and then that should relatively work. There's probably some errors that I missed. Yeah, but we'll see. Cur row is the first one. C, cur row plus C. Okay, I don't know why. Why are we adding strings? Oh my god. Okay, yeah, that makes sense. This is not a value. Okay, yeah, hold on. In range. Yeah, there you go. Wait, is this an integer? Hold on. Board of this. These are a list, right? Okay, wait. Why am I doing this? Let's call this. Yeah, call rows. I don't want to mess anything up, actually. I actually should, because this is gonna rest. I call this calls. D1, D2, answer. Okay, because I need to make sure that I don't mess any of these up. Call this call this call. Because the reason why I'm doing this is because there's a lot of the thing here, and then we'll do for range if n, and then for row that call, and then we add it to calls and rows, and then we pass in rows, calls, not res, answer, and then row dot discard. This row dot discard is call discard is call. Oh my god, this is so disgusting. There's so many errors. Did I miss anything? Okay, yeah. After that, that's it. It's pretty simple, I think. I don't think it's that terrible. And it should generate all the set like all the different variations there is. Okay, of course, cur, call. Okay, yeah, that doesn't make sense. Oh wait, why are we adding it twice? We should not be adding it twice. We should add it to D2. Actually, I don't want to return. I just want to continue. There's no point of returning early. There could be like better ones in the future, you know. Like for example, I couldn't add any of these, but there was one right here, right? Okay, Kuro, there's no column, it's just Kuro. Discard, Kuro, yep. Kuro, call. Discard. Okay, blue bear. Oh my god, we've added way too many combinations. Wait a minute. First off, these don't look like groups of 4. Okay, so that means I need to grab them like this. No, not everyone. Okay, I want to add them to answer. Wait, yeah, that doesn't make sense. Wait, why am I passing in board and column? Actually, hold on. Oh, I need to add it to res. Okay, actually, I'll just call res. Yeah, I'll call res. I don't even need to pass it in. I'll just call it boopable. Put this here so it's fucking readable. Create the board, the res meaning the answer. Res.append. No, I need to res.append a list. Yeah, it's fine. We'll do answer like this. Cur row. No, this is board, and then ants, and then we'll do ants. Where's the append? Ants, and then I need to adjust the call to not call this anymore. This is basically undo it, and backtrack, and don't pass it in as well. Just call it, and then okay, yeah, pretty straightforward. Okay, better, but I'm actually adding way too many. You know? Okay, I don't know why. Maybe I do need a return. Yeah, what if I do need a return? Okay, a lot better. First off, these are fine. Okay, there's a confliction, yeah. That doesn't make any sense. Minus call plus call. Call is the discard call. Let me try moving this. Hold on, maybe I should just pass in the board so it doesn't conflict. Yeah, maybe I should pass the board in. Backtrack, board. I'll pass the board in. board, and then we add it to the answer. Yup. Hold on. Should I skip it or not? I don't know why it's like causing so many different combinations. Should I also remove it actually? If I can. Let's do remove actually. Remove. Remove. Yeah, what about removal? Does that make a difference? Okay, there is a key error. Oh. That's actually really weird. It shouldn't do that actually. That's kind of weird. I don't know what I'm doing wrong here. Oh my god, hold on, my base case. I should be this. I want to be at the like I want to do the last roll as well. Yeah, I forgot that part. Rest up pen. Yep. Oh, I don't do a check here. Curl or call in calls? Yeah, I don't do that. Yeah, for some reason, yeah. Oh, better. Maybe this works. Alright, perfect. Alright, see you guys tomorrow.